All right. So it is asking for the order of the reaction of the decomposition of C4H6 at 45 degrees Celsius. So it provides a table, and to find the order of the reaction, you have to figure out if if the time versus concentration is linear, if time versus the natural log of concentration is linear, or if time versus 1 over the concentration is linear. Or in easier terms, find the R value that is closest to 1. So to do that, we are going to go to our regression app. And first, we are going to plug in all the values that's given. So first, in our X column, we are going to plug in our time. Remember that X will always be time, no matter what. So first, it's going to be 0, then 1,000, then 1,800, 2,800, 3,600, 4,400, 5,200, and finally 6,200. Now, in our Y column, we're going to have to plug in our, our molarity. So at time 0, our molarity is going to be 0.01, then 0.00625, then 0.00476, and 0.00370, 0.001, that's 313, 0.00270, 0.00241. Oh, sorry. And finally, 0.00208. Now, to figure out the order of the reaction, we are going to have to see first the natural log of the concentration, and then finally 1 over the concentration to see which value is linear. So to do this, first let's go over to our next column, x2, and now we have to plug in our time value. An easy way to do this is highlight x2, press OK, then fill with the formula, then empty, and just press Alpha Shift X1. So now it is going to fill in all the values with our X1 values. Now we're going to do the same thing, except we're going to fill the formula with the natural log of Y1. Now it is going to give us all the values in Y1, but the natural log of it. Now we're going to do the same thing with our final column. We're going to go empty, Alpha Shift, X1, then Y3, fill with a formula, empty, now 1 over Alpha Shift, Y1. So now with all these values, we're going to go to stats to figure out our R value. So if we scroll to the very bottom, it's going to have our R value, and we have to see which one is closest to 1. Oh, so as you can see, um, our third column, the R value, is closest to number 1, thus making the reaction a second order reaction. Now we have to find our rate constant K for the reaction. So now that we figured out it's a second order, we know that we can use the following formula, and we're just going to plug in all of our values, solve for K. So I'm going to pick uh, the final value in our reaction, 0.00208 at 6,200 seconds for our reaction. Okay, So now we're just going to solve for K. I'm going to move the molarity to the other side. So 1 divided by 0.00208 minus 1 over 0.0100. Now I'm just going to divide this value by 6,200, where I'll get a final K value of 0.0614. Now we get to find out at what time is the concentration of C4H6 0.0015 molarity. So again, we're going to plug in our values, except this time we're going to solve for T. Okay? We're going to go back to calculation and we're going to isolate T. So 1 over 0.0015 minus 1 over 0.01. Now we're going to divide this by our K value that we just calculated, where we are going to get 9,226 seconds. All right. Now we have to find out the concentration of C4H6 at 7,000 seconds. All right. Again, for the same formula, we're going to plug in our values, except this time we're solving for the concentration. Now I'm just going to calculate all of this out. So 0.0614 times 7,000 plus 1 over 0.01. That's going to get us 529. Now we're just going to divide this by sorry, we're going to divide 1 by 529 to get our final concentration of 0.00189 molarity.